Episode 15 Troubleshooting Pigment-Related Defects, Fading, Chalking, Flocculation and Color Shift in Automotive Coatings. In this final episode of the Pigments Masterclass series, we explore the common pigment-related defects encountered in automotive coatings and how to diagnose, prevent, and correct them. Despite careful pigment selection, formulation, and processing, coatings can exhibit visual and performance issues due to pigment behavior, interactions, environmental exposure, or processing errors. Understanding these defects is critical to maintaining high-quality automotive finishes and meeting OEM standards. Fading is one of the most common pigment-related defects, typically observed as a loss of chroma or a shift in hue over time. It is most prevalent in organic pigments, which are sensitive to UV radiation, heat, and chemical exposure. When high-energy photons strike organic pigment molecules, they can break chemical bonds, generate free radicals, and lead to molecular degradation. The result is a visible change in color or brightness. Fading can also occur and affect pigments if flake orientation or surface treatment is compromised. To prevent fading, formulators use UV stabilizers, hindered amine light stabilizers, HALs, and protective clear coats. Proper dispersion and surface treatment of sensitive pigments further enhance their stability. Chalking refers to the formation of a powdery residue on the coating surface caused by the degradation of pigments and binder at or near the surface. It is often associated with high PVC coatings, or those containing organic pigments that have insufficient UV or chemical protection. Chalking reduces gloss, alters color perception, and can lead to uneven appearance. Preventing chalking requires optimizing PVC and CPVC, selecting durable pigments, and using protective clear coats with UV absorbers and antioxidants. Accelerated weathering tests such as xenon arc or QUV testing can help predict chalking susceptibility. Flocculation occurs when pigment particles aggregate or reagglomerate after dispersion, leading to streaks, haze, color inconsistency, or reduced hiding power. This is commonly caused by inadequate dispersant selection, poor milling, or chemical incompatibility between pigments and binders. Flocculation is particularly critical in effect pigments and high surface area pigments, where particle aggregation can destroy visual effects and uniformity. Controlling flocculation involves optimizing dispersant type and concentration, controlling pH and ionic strength in aqueous systems, and carefully monitoring mechanical dispersion parameters. Rheology modifiers can also be used to maintain stable suspensions and prevent settling or aggregation during storage and application. Color shift can occur when pigments undergo chemical, physical, or optical changes, resulting in a visual change in the final coating. This can happen due to interactions between pigments, incompatibility with the binder, environmental exposure, or incorrect layer sequencing. For example, combining certain organic pigments with reactive extenders or incompatible dispersants can lead to chemical reactions that alter hue or reduce chroma. Similarly, effect pigments can change appearance if flake orientation is disturbed during application or by subsequent layers. Preventing color shift requires careful pigment selection, surface treatment, binder compatibility, and precise control of multi-layer application processes. Other pigment-related defects include gloss loss, hazing, mottling, and orange peel. Gloss loss may occur due to excessive extender loading, poor dispersion, or surface roughness caused by large pigment aggregates. Hazing or haze occurs when pigment flocculation or insufficient wetting causes microvoids that scatter light. Mottling or uneven color can result from inconsistent pigment distribution, while orange peel can be caused by poor leveling influenced by pigment particle shape, rheology, or application conditions. All of these defects highlight the critical role of pigments in determining the final film appearance. Environmental factors such as temperature, humidity, UV exposure, chemical contaminants, and mechanical abrasion can exacerbate pigment-related defects. For example, high humidity may induce flocculation or binder pigment separation, while prolonged UV exposure can accelerate fading or chalking. Coatings applied in uncontrolled environments may exhibit inconsistent appearance due to differential drying, pigment settling, or flake misalignment. Controlled application conditions, proper formulation, and protective measures are essential to mitigate these risks. Advanced analytical techniques are used to diagnose pigment-related defects. Spectrophotometry allows precise measurement of color change and fading. Microscopy can reveal flocculation, agglomeration, or flake misorientation. Surface profilometry evaluates gloss, smoothness, and defects like orange peel or microvoids. Accelerated weathering and chemical exposure tests provide insights into long-term performance. These tools allow formulators to identify the root cause of defects and optimize pigment selection, dispersion, and processing parameters. Preventive strategies include careful pigment selection based on stability, compatibility, and functional requirements. Proper dispersion, controlled milling, and the use of dispersants, rheology modifiers, and stabilizers are essential to maintain uniformity and prevent flocculation. Multi-layer system design, including primer, base coat, and clear coat sequencing, ensures that pigments maintain their optical and protective properties. Protective additives, surface treatments, and optimized binder chemistry further enhance pigment performance over time. In summary, pigment-related defects such as fading, chalking, flocculation, and color shift are major challenges in automotive coatings. They can affect appearance, gloss, durability, and overall quality. Mastery of pigment behavior, selection, dispersion, surface treatment, and multi-layer system design is essential to prevent these issues and achieve consistent, high-performance automotive finishes. Understanding the causes and solutions for pigment defects empowers formulators to design coatings that meet stringent OEM standards and provide long-lasting, visually appealing results. If you have any questions about pigment-related defects, their causes, or how to troubleshoot fading, chalking, flocculation, or color shift in automotive coatings, leave your questions in the comments and I will clarify them.